Okay, welcome to my presentation about the do-it-yourself knowledge graph, which is an idea for continuous ontologization in reference to continuous integration and to express something dynamic and ongoing. Yet another title would be an ontology design assistant working with you towards continuous expansion and integration. I started implementing parts of this idea, so this presentation will be a mix of conceptual slides and demoing my prototype. This was my private side project over the last few months, and I could have tinkered around with it for much longer, but I thought it's time to put it out there and see what people think of it. Plus, presenting it really helps getting my thoughts about it more organized. I apologize in advance if I'm using terminology slightly or completely wrong. I am not currently active in the community and not very well connected to the academic research. Okay, feel free to skip this next part if you want straight to what it is about, because the next slide is about 2 episodes in my career so far that were relevant for this idea, among other influences that found their way into this idea conglomerate over the years. In my master thesis at Fortis in Munich 2019, I worked on the semantics of robotic grasping. Here a screenshot showing a match between a gripper and an object to be grasped. The object has 2 flat surfaces that are parallel and face outwards. We can see only one of them highlighted here. The gripper is semantically annotated with the capability to grasp objects that exhibit such a geometric feature, and it can do so using the highlighted surface and the one on the other side. Of course, before actually executing the grasp like this, a rotation has to take place also. Here are 2 more examples of matching grasp modes. The dent on both sides of the gripper here can be used to grasp cylindrically outwards facing surfaces, whereas this little thing here goes into cylindrical inward facing surfaces and then spreads out until it touches the surface. Here screenshots of what it looks like when these grasp modes have closed in on an object. The objects themselves are different than in the screenshots above, but the grasp modes are the same. The ontology to describe 3D objects is called ontologization and was developed by Fortis. I extended it with vocabulary to describe these geometric features and wrote scripts that can find them automatically. Furthermore, I modeled the capabilities of grippers in a way that works with these geometric features. Finally, as a new step in their already existing assembly pipeline, all there was left to find matching grasp modes was to run a Sparkle query. Of course, as a step after that, there is still numerical computation necessary to find the points within a surface to target and how much pressure to apply given a certain friction, etc. But the great benefit of this approach is to be able to reason about grasp modes and get helpful error messages if none are found, for instance. It also cuts down the computational effort enormously compared to classical grasp planning that would sample millions of options randomly to find physically meaningful ones. I enjoyed it a lot to get into this way of thinking, especially in contrast to much hyped machine learning approaches that seem to go from the outside in through sheer training data quantity, but without an understanding of what it is learning. In contrast to this, I like this approach of modeling knowledge from the inside and have results that are always perfectly reproducible along a chain of reasoning. Constructing the ontological vocabulary I found to be a very interesting but quite time-consuming challenge, with going back and forth what might be the best way to model it. Small changes on one thing might mean having to rethink other parts as well, etc. Ever since, I was wondering if it could be made easier to construct ontologies. After all, the idea of a lot of ontologies is to make the knowledge of human experts widely and quickly usable. So maybe it's also worth thinking about how the expertise of modeling ontologies can be made more accessible itself. The other episode I'd like to share is from my freelance work for Graphdb, Germany's data portal. They host the metadata that various providers deliver to them following the DKIP-DE model. Among other things, I helped evaluate different pipeline architectures that would provide data for metadata quality dashboards. Furthermore, I created a lot of Sparkle queries to showcase examples on how their newly opened Sparkle endpoint could be used. Here is a query that gives the average amount of distributions per dataset. A dataset would be, for instance, the rivers in Bavaria, and then it would contain a distribution as CSV file and a distribution as Excel file. A big takeaway from that time was for me that more data is better than less, and the more linked the data is, the better. The justifications of why that is the case usually comes later, as it enables unforeseeable things. Okay, before shifting to demo mode, let me outline the basic ideas or design principles that I would like to see in this. First of all, it should be free and open source software. Secondly, it should make it easy to design ontologies, basically triples first and refinement later. The data should get better over time. Ideally, the barrier of designing an ontology gets lowered to a level where anyone feels like they can start feeding triples into the system and arrive at something useful over time. Instead of me having to do all the hard thinking, putting it into Protégé and getting frustrated with how to set things up and running into reasoner errors, I want a welcoming interface that accepts almost everything I throw at it and then works together with me to improve it over time. You can start by putting in a triple like Benjamin is human, and a default namespace will be used for the URI for you not to have to choose one right away. You should be able to wake up in the middle of the night, throw a few triples in and go back to sleep. So the slogan would be something like, good things happen when your triples live here. After a ramp-up time of goodwill, the benefits of building a knowledge graph should become tangible. I would like it to become your creative attractor that you want to feed because you're getting good stuff back. So the whole thing should be set up for discovery and unexpected insights and synergies. I would say though that the basic assumption should be that there is a best way of modeling a given topic as ontology and that we should get there over time. Be it because it is the most integrated version with other vocabularies out there or because it's the most salient or most causally correct representation. The system itself should also be fundamentally open for unexpected innovations and be maximally extensible. It has to be easy to add all kinds of components. With reverse analysis here, I mean to have mechanisms in place that try to open the door for building features that could help with something that happened manually so far. Definitely maximum data portability at all times, import from and export to all kinds of graph formats in triple store, and anything else someone might want to write an importer/exporter for. As I'll show you in a minute, in the implementation I use a triple store and a graph structure in parallel at the same time in order to harness the features of both. It's totally possible though that this is not necessary and there are good on-the-fly conversions, etc. out there. Alright, let's have a look at the prototype. This is the repository, you can have a look. The main technologies used are Java Spring Boot for the web server, Apache Jena for the triple store, JGraphT as the graph library, and to test importing from and exporting to graph databases I use Graphdb. The part about visualizing Sparkle queries is in its own repository because I thought it might become useful somewhere else too. Alright, demo time. The example I'll be using is a fictional product called the Flower Potuino. Let's see what it is about. Over the course of the demo, it should become clear. Let's start with the front end and work our way backwards. This is a very simple page that is served from the Spring Boot web server. It is not a React app or something fancy, it's just an HTML file with some JavaScript. Eventually I would like to build more clients in various forms, a shiny web app, a command line utility for a pure and fast experience, a Telegram bot for throwing in triples in the middle of the night, etc. Let's add our first triple. We start with my product has name Flower Potuino. And this is a literal in this case. And we're keeping the default namespaces and we add this statement. Okay, we can see over here that it was added. Also here we get a confirmation that also says that all the 3 entities used are new in the triple store. And we also got our first suggestion from the local vocabulary matching task saying has name has been found in an existing vocabulary, namely the W3C vcard ontology. There will be this URI. So let's use this one instead of our default one. So we're gonna accept this suggestion. And what we can see is that it got replaced indeed. Alright, before adding more triples, let's have a look at the server code. So this is the central class, the model controller. Here we see the WebSocket routing is auto-wired as well as a suggestion engine, 3 Jena models. The graph manager contains all the graph handling. in the beginning we read in all kinds of properties from the property file, and we initialize our models. If they are already in the TBT directory over here, they are getting used, otherwise they're getting created in that data set. So here we have the main model, the meta model, and the vocabulary sources model. We'll see in a second what these are good for. Let's have a quick look into the Graph Manager, what's happening there. So this one does not have its own persistence solution. So what it does upon start, it's reading all the statements from the main model, and for each of them importing them, meaning adding vertices for statement and object and then connecting them with an edge. All right. Now let's see what happened when I submitted that first triple earlier. I'm going to leave out the WebSocket routing code, and let's instead look at when it arrives here in this method. So first we're creating a statement out of these three entities, and if it's already in the main model, that's it, we're going to return right away. Otherwise, we're going in here and we're storing a new triple event in the meta ontology. I'll show later what that is about. Here it gets actually added to the main model, and here we're importing it to the graph. And then we're going back here, we're broadcasting to all the listening clients that a new statement was added. And we run a new statement job in the suggestion engine. Let's have a look what that means. So these jobs get run upon adding a new statement, in contrast to periodic jobs that happen repeatedly in the background automatically. So the new statement job has two tasks, namely the local vocabulary matching task that we already saw an output from, and the Wikidata matching task. This one is more for experimentation at this point, because I'm not super sure how to actually make the integration, because the items it finds based on the label have, of course, Wikidata IDs, and they're not super readable, and so far my visualization builds on them being readable directly in the URI, but that might have to change, or I could think of something like linking the items through the meta ontology. Okay, yeah, this is where periodic jobs are scheduled, so every 30 seconds we're running a periodic job that at the moment only looks at the case sensitivity task. We can see what that is about. So let's say my product also has a module flower pot. Adding this. And it has a module, this time on purpose with a small m. Here we see the Wikidata matching task suggestion coming in. Has module sensors. And now, within 30 seconds, we're gonna get there we go. The case sensitivity task says these URIs were found to use the same word when compared case insensitive, consider merging them. And we will happily do that, either again by accepting the suggestion ID or by running the achieving command. Of course, a nice GUI would have here just a button of accept or reject. So, and then we can see that has module has now this same camel casing. Okay, now let's add some more triples, so we have more substance to show some more features. My product also has a compute module, the Arduino, hence the name of flower pot. Okay, then the sensors contain infrared camera. Furthermore, they contain a humidity sensor. And the humidity sensor is required for the mint token for watering feature. Mint as in creating a token on the blockchain. And the infrared camera is required for measuring the plant health. Okay. Now we have some nice triples over here. And let's see what we can do. We can export it as RDF, either the main or the meta model. Let's export the main one. We can also export it as GraphML and as Graphdb, where this is the rule set of the repository. Let's also export the meta one. Okay, let's have a look at what all of that did. So here in the export we created an RDF representation of our main model. Yeah, the prefix is not super nice, but it is correct. The GraphML means that we can use now, for instance, yadd. We run a layout algorithm and we see this is our graph so far. Cool. What else happened? I also exported to Graphdb, right? So we can see here there's a main one and a meta one. Both of these I exported. Let's see what's inside. Yeah, and the main one, we have 8 triples so far. These are literally exactly the ones we inserted through the front end. In the meta one, we have a few more though. 123 triples already. And that is because I'm following a strict ontology here that I came up with myself. Just to experiment, there's definitely room for improvement. So we have a triple that has object URI, predicate URI, subject URI and stuff like that. And then we have event that has always info and a timestamp. And then we have a new triple event where the triple is attached, and modifications event where I have a URI's rename event. Yeah, and in terms of object property, only this one has triple, and data properties we have a few. Has info, has timestamp, rename from, rename to, and stuff. This is what happens when we store a new triple event here. So we're basically adding an individual of the class new triple event, and the same with the renaming. So what we should be able to see now, event. Yeah, and what that means is that we can now run queries like this one, for instance. That gives us the entities added to the triple store ordered by timestamp. Other queries might focus on tracking patterns of entities through modification events. Now let's look at the part that I outsourced into another repository, the graph query visualizer. I was looking to implement something like property changes into the suggestion engine to have if this then that kind of mechanisms. So I tried to go with Sparkle construct queries in conjunction with a way to visualize them as graphs. But let me show you that's easier than trying to explain it. So what I'm gonna start typing here is the my product as module, and then a variable module. And as you can see, while I type here, it changes here in the graph visualization, and also over here in the natural language visualization, kind of. So what I can do here now is make component, and then that was the physics engine kicking that away. The module contains the component, and the component is required for the feature. And as I was doing this here, the Sparkle query automatically wrote itself, and the natural language output sort of makes sense, right? My product has module that contains component required for that feature. Yeah, as you can imagine, that natural language output is very tricky, and it brought me close to diving into NLP, or natural language generation more specifically. The implementation here is very simplistic. I'm basically looking for the longest branch and use that as main sentence, and then side branches will be inserted as subordinate clauses at their respective starting points. I can't wait to see the approach abstract Wikipedia will take by assembling functions from wiki functions to generate natural language. My short dive into trying to translate Sparkle queries to natural language sensitized me a bit for the challenges this involves, I think. Now we can run this query, and we see we get two results, namely the component of infrared camera is required for the feature of measure plant health, and the humidity sensor is required for min token for watering. And what I tried to do here is, when you click on it, first of all you get the sentence filled in with the result values for the variables, and down here it arranges itself in the same positions like up here, because I wanted to close that loop. Like, okay, this is down here we have a graph with much more stuff in it, but these are actually the results, and to make it visually clear it's in the same order. But yeah, it needs a bit more work. I think it's not really obvious what I tried to do. Click on this, and you see the results with the otherwise graph around it. Yeah, I'm sorry for the hard cut in the video. I forgot to show one thing on this page, because the whole idea of trying to translate the whole thing into 3 different domains, right, from Sparkle query, natural language, and graph, is to make it easier, more accessible, or sort of almost like a Sparkle training, if you will. And an important part is this whole triggering, or this whole construct thing. If this chain here finds results, what I want then is that here we add something new, and that is has feature, right? So this is now a construct query. When this is the case, I want a direct connection from the product to the features. And the natural language formulation, if this is the case, there was a sentence like before, if this is the case, we infer that my product has feature. Yeah, so that part is not, I can't submit that now, but eventually I want to integrate this as a type of suggestions that pops up after you previously programmed it in like this. As the last part of the demo, I would like to show a bit more sophisticated type of vocabulary suggestion. I have to admit right away though that is a bit hardwired in the code for the purpose of this demo. So eventually it needs to be thought through and integrated properly. So let's actually define has compute module as a subproperty of has module. And what that should trigger now exactly is a suggestion saying you should use RDFS subproperty of to make the connection inferable. And then there's a longer command how to do that. It replaces one URI and adds 2 times the object property, namely has compute module and has module have both to become OWL object properties. I'm gonna go ahead and accept that suggestion. We're gonna export to Graphdb again, but this one not with the empty rule set, but with a rule set that actually allows us inference, and it will be this one. So now we can see that there's a third repository, and here we can now try this once without inference. We get the 2, my product has module flowerpot, has module sensors, and as soon as I turn on inference, we also get the third one, the has compute module Arduino. yeah, I don't know how common it is to have only some triples follow an ontological schema, whereas the others do their own thing. But this is exactly what I'd like to encourage with this tool, to start messy and improve over time. The user will have their own learning curve with this and will keep getting prompts, and maybe eventually most triples or relevant subsets of it are conform with a strict ontological schema. Okay, back to the presentation. This next part I wish would have also been part of the demo, but I don't have any implementation to show for it yet, as I didn't come up with a good software architecture for it yet. Alongside the kind of suggestions we have already seen, I would like something more sophisticated to stimulate the growth of your graph. It should be more intentional and with a longer breath, so to say, than just a bit here and there. For want of a better word, I call them wizards for now. Let me show an example what such a wizard could help us with in the case of our flower Potuino example. Note that this will sound partly very much constructed for this demo, and as I said, I have no clue where to start implementing it, but I think it could be amazing, so let's see. Wizards, or we can also call them assistants, are following archetypes, or we can call them dialogue-based patterns too, maybe. Meaning someone thought about a more or less choreographed way how to set up a structure and generate stimulating questions. Here we have the create packaging for existing product archetype that is used. As existing product, we have our flower Potuino with the triples you have already seen. To have a bit more to work with, I added 2 branches. One about the target group being beginners, and one about the overall concept of this product, namely being a self-assembly kit. Now let's look at the packaging side. So nothing of this exists yet. Our job is to design a packaging that is used to ship our product to customers. Whoa, the emoji went down there. We have 2 requirements given, namely that the product arrives intact and that the material is cardboard. Alright, this is basically the starting point where we activate the interactive part of the wizard. Its job is now to look at the 2 graphs and probe into new, potentially helpful connections between them. Also, extending only one graph at a time is a valid step in the process. Let's see what this could look like. The first stimulus, meaning the first question or first prompt, is probing into a potential connection between the Arduino and the product arrives intact node by asking, how can Arduino help to meet the safety requirements of product arrives intact? After thinking about it, we conclude this is a useless question. So, okay, let's see the next one. What is a main characteristic of self-assembly kit, given that the target group has the expertise level of beginner? Okay, that's more interesting. Actually, the kit should be self-contained, so that our customers can get going directly with it without having to buy more stuff. Great. What's next? Does self-assembly kit fulfill self-contained completely? I guess the wizard looked into some other ontology and found out that should be implies completeness might not be reached, and therefore decided to probe into this. Very clever. So yes, right on point. We are missing a plant to put into the flower pot and the earth to plant in it. So we have 2 does not contains. Next is a question taking the new Earth node into account. Is there a useful link to be made between infrared camera and Earth? Well, not really. Next one. If it does not contain Earth, can we find an alternative that helps fulfill self-contained? So the wizard is still on about this lack of completeness. So yes, I guess we could include a substitute, something that does not start decompose while the package is in transit, but then starts fast with composting, so a plant can grow on it. Actually, why not find a filling material that has this feature? There must be something. And at the same time, this solves the requirement that the product is well cushioned during transit. Cool. Okay, one more question, please. We solved one does not contain with one package requirement. Can we solve the other does not contain with the other requirement? So it seems we had some logical reasoning going on here. If one requirement led to bringing us one step closer to self-containment, maybe the other requirement can help with the remaining issue. And yes, I have seen postcards containing seeds where you can just plant the whole postcard and flowers will grow. We could use this for our cardboard packaging, and our customers just rips off a part with seeds of their desired plant in it and plants that. we could have differently marked seed areas on the package. Okay, one more slide on the wizard topic, and this is basically now just a collection of a lot of thoughts I had around it. So in terms of implementation challenges, I was wondering, how do you select subsets of nodes to formulate prompts around? Is it just random, or is there a more strategic way of going about it? What angle do you take in formulating your prompts? How do you add answers back into the graph that don't easily fit into the patterns of triple? What would be amazing is if the whole wizard process itself could be formulated as a graph with probabilities at bifurcation points, because then the materialization at each step speaks for itself and there is no need for another way of keeping track of the process. We definitely would need a wizard helping to create wizards, and the support should be for very different types, from very generic to very specialized niche wizards. From 0 to something, I mean something like, I have no clue what to insert, just ask me how my day was or something. Would be so cool to try to recreate existing creativity techniques in this wizardy way, so a design thinking methodology or something like that. I was thinking about using Rasa as a dialogue system framework, and I'm worried that the system would generate a lot more useless prompts than useful ones. So in the example earlier, we had only 2 useless ones and more useful ones, but in reality I think it will be very much the opposite. So basically, when would the user get frustrated and stop engaging with such a system? How could it be ensured that they're at least somewhat to very useful? The great advantage of using this as a sort of creativity stimulating technique is that it combs through all of the combinatorial space instead of focusing on creative hotspot or something that always worked that we do it that way. I could see collaborative features emerging around this, like you could parallelize the prompts so co-workers cover more ground together. I could manually add a prompt and have that sent out to co-workers. We could compare different answers statistically and highlight the differences between them as a starting point for discussions. Maybe the product manager could mark areas as hotspot to intensify the prompts around them to really get some creativity going on these parts. It could be cool to collaborate with machine learning algorithms. So I guess what creative professionals do a lot is to start with mood boards, and I guess they could be analyzed with machine learning algorithms to quite a degree, to the color schema, what kind of shapes are there and stuff, even what objects do you see on it, and you start constructing a graph from that. And then hand it over to the user in a wizardy kind of way. And the philosophy should be like, just ask and take it from there. So instead of deriving everything with machine learning, the key idea, let's ask the user, let's ask them. They have the creative intelligence, what's going on there? But then keep nudging the humans into different perspectives and contexts to systematically increase the probability for creative insights. Okay, and in this context, analogies could actually be seen as test copying a branch from one context to another to see what makes sense. To get a bit of a summary over the graph operations I discussed, I organized them in 3 columns: self, expand, and consolidate, where self means about the system itself, and expand and consolidate refer to the type of work on the graph. Is it more about growth or more about maturing? The meta-ontology I showed you in Protégé to be used for timestamping entities and triples, to track modifications, and the way I set it up at the moment is that it's purely additive, right? So you could even, if you fancy it, make a distributed ledger out of it. Expand, yeah, basic philosophy, just toss triples in and refine over time. These construct triggers I showed you with the visualization of the Sparkle queries. Yeah, wizards, as we just discussed them, with archetypes, and as stimuli patterns in meta history and graph similarity. So what I mean with that is that when you go along a branch in a graph, you're still you're following one similar thing to the other, but what could be really cool is to get unexpected cross insights or cross test connections across the graph is when you say these entities have nothing to do with each other in an obvious sense, but they have a very similar meta history. So they have been modified in the same way, and they have been integrated in other constructs in the same type of way. Is there anything interesting to it? Why did that happen that way? Or they are similar in the graph around them, so they have the same number of first and second degree connections around them without looking at what these actually are, just the structure of them is similar. And why is that? Is there something interesting to it? Maybe that can bring unexpected insights. In most cases probably not, but again, in some cases it could just spark something interesting. With that I mean something like you have used 80% of this controlled vocabulary. Why not look into some more of it to go 100%, if that makes sense. And inviting contributors to also expand the graph. Okay, the consolidate part shouldn't come up all at once, but suggestions either ad hoc or periodic. You've seen the merging of case sensitivity. Typos would be cool, thesaurus would be cool. You've seen replacements. Linking would be cool for Wikidata items, for instance, or anything from other knowledge bases. Pruning, don't know yet how to do that. Zoom layers is also an idea that needs much more thinking about it. That you can basically say this long branch with subtrees in it. This is basically the extended version of a smaller one. Like this is the summary, and this links to this one, so you can like zoom around in the level of detail. So basically, I would love all of these tools to feel like a scaffolding, right? So you can shift around lots of nodes at once. You have powerful graph algorithms at your fingertips. You can merge, you can rebase, and the changes you make in this way are less expensive. It's easy to update, so you don't have to. One change here means I have to redo all of that, so I'll better leave the ontology as it is. The whole idea is that it should feel dynamic and easy to do these things. Okay, I was hesitant to even start listing use cases because the danger is that everything now gets judged by how much sense the use cases make. I believe such an open system will justify itself over time and lead to insights and use cases that can't be predicted beforehand. Let me just sketch out a few things, nevertheless, that I thought about. Of course, one proof of concept would be that I can recreate my master thesis just by following this system. Or, take other ontological reasoning systems and start like, this is the desired functionality, in my case the matching of gripper and object, and work your way backwards. What's required to have this here. Okay, use case literally pour in everything in the middle of the night, just anything I can think of for days and weeks and months. I just put everything I know into it and see what's going to happen. Or use it like a diary, harvest interesting stuff into it at the end of the day. Track learning in school or university. In public administration, like when someone moves to a new place, you could use these triggers to, like, in a structured way, all of these things happen when they register a new address. Based on our requirements for a project, what tech stack would you recommend? Social setups, mapping those in that way, and then you can say, like, in this arrangement, abuse of power often happens. For instance, if we would put all mathematical and physical formulas in, could you find unexpected similarities? Like, let's say the formula for how asphalt is cooling down over time, and then there's this formula how sound waves of singing whales travels underwater. And then the system says, look, this part under the integral with these 7 variables actually shows up in both of these formula. Like, not the actual variable names, but the structure of it. And then you're like, wow, this is really interesting. No one thought about it because that part of the formula didn't have its own name or own concept. But nevertheless, you find these similarities. So that, I don't know if that's realistic to happen, but Okay, what's next? I would love to hear from you what you think about it, if you want to share your thoughts. I really want to try it myself to come to a point where I have a little server running day and night and I can just input stuff and take it from there. I would like to integrate what's out there. There's probably a huge overlap with a lot of initiatives and research that I don't know yet about. I really would like to get going with developing prototypes for wizards and archetypes if I would just have a crystallization idea for the implementation. Federated virtual repositories would be cool, so that I can include all of Wikidata, for instance, even so I don't have it downloaded on my machine, so work lightweight in that sense. And I guess the whole triple business is quite factual and static, and it describes things in a logical way, and that's not always how things work. So event-based component and numerical things have to find their way into it eventually. And I was thinking maybe all of this whole thing that I showed can be realized using Wikidata and Wiki functions when it comes out. That would be amazing. Or Wikibase has already parts of it. Basically, I don't need to add new software when there is great open source stuff out there that I can integrate it with some thoughts. Okay, that's it. This is my GitHub username. This is the repository, and I enabled the discussion feature. If you want to leave your feedback in public, you're more than welcome to do so here. Otherwise, this would be an email channel, Telegram or Twitter, and that's me on LinkedIn. And that's the end. Thanks a lot for your time.